the vector in F in the vector space such that the inner product of phi times phi and u is 0 for all u in S. Yeah. So if S is the empty set, then S pub is defined to be the whole of vector space. So if S is subset of vector space, then S pub is subspace of that vector space. And the subspace generated by S, and if we take the perp, and then this is the same as S perp. And this is for the using in the quantum stabilizer code, and we define the Hermitian inner product. We use the vector space is over the complex number. So the inner product is defined like this. So this is the property of inner product. So this is the theorem that we are going to use for linear code. That is dimension of subspace generated by S plus dimension of S pub is the same as N. Yeah. We continue on the linear code. Yeah. A linear code C of length N over FQ is just a subspace of FQ to the N. Yeah. So this is the example. The repetition code, that this C is the set of lambda, 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 where lambda is FQ. This is a subspace of FQ to the N. So this is a linear code. And then the ternary code, yeah, that is the code over the F3. Yeah. This is a subspace of F3 to the 4. And if C is linear code over FQ, that is C is subspace of FQ to the N, then the dual of code C, denoted by C pub, is the orthogonal complement of the subspace of C. That is all the vector that is orthogonal to C. And then the dimension of C, denoted by dim C, is the dimension of C as a vector space of over FQ. So the dimension of linear code is the same as dimension as the C considered as a vector space over FQ. And then this is the basic property. Given a linear code C of length N over FQ, then the number of code word is the same as Q to the dimension of C. That is, the dimension of C is log of the number of C. And the second property is that C pub is linear code, and the dimension of C plus dimension of C pub is N. And if we take a perp on the C pub, then the result is just C itself. This is just a notation. Yeah. A linear code C of dimension K is often called Q array. The notation is just the curly bracket, the brackets like this, and K code. Yeah. Or sometimes NK code Q. When Q is clear from the context, it's usually just omitted. If C has a distance D, then we can write that linear code of length n of dimension k and distance d is just like this nkd code. This is a code, a linear code of length n, a dimension of k, and the distance of d. And then a linear code is said to be self-orthogonal if C is a subset of C perp, and self-dual if C is just a C perp. This is the consequence of the property that if C is self-orthogonal and K orthogonal, then K less than or equal to n over 2. And C is self-dual, then n is 2k. And then the third is every code word in self-orthogonal, that self-orthogonal if C subset of C perp, then every code word has an even weight. We know that C, inner product of C and C is 0. So it's only happen when the number of weight is even. And the weight of any code word C, noted by WTC, where C is self-orthogonal code, must be divisible by 3. This is just the explanation. This is an example. If Q is 2 and C is like this, we know that the dimension of C is 2. So the dimension of C is 2, so C perp is just C. This is self-dual. This is an example of whenever K is 3 and n is 5 and C is like this, we have 5 to code over F3. This is the length of 5 and dimension of 2. All the non-zero code word in C have weight 3. All except 0 has a weight 3. So C is self-orthogonal, but C is not self-dual. Since n is 5, is odd. This is the relation between weight and the distance. For two vector V and W, with the distance is d VW, is defined to be the number of positions where their respective entries is disagree. And the weight of a vector V to be the distance from the 0. So the weight of vector V is the distance between V and 0. And if V and W is in FQ to the n, we have the distance between V and W is the same as weight of V minus W. And we have the property that if C is linear, then the distance of C is the same as weight of C. So the width of C is